Today we're going to review static fluids.
I have a piece of cedar wood here. It has a length of about 8 feet, and I need to cut it into a section that's only 4 feet from my garden. Now that I've cut the wood, it's half the original length, half the original volume, but also half the original mass. So the one property that has not changed about this is its density. Density is a way of identifying substances, because all substances that are made of the same thing, if they're pure, will have the exact same ratio of mass to volume. That's what we refer to as density. Here's my compost pile. It was once much bigger than this. I've been spreading it around in the garden recently. And you'll notice that it's made up of really tiny particles. But still, these tiny particles, you'll notice that I'm able to put them in different shapes, and they pretty much are able to maintain these shapes. With our true fluid, water, it can take the shape of its container. So when I have my water filling up any of these different containers, the water will take on the shape of the container. Water does not have memory. It doesn't know what it's supposed to look like. Now you'll notice I filled both of these containers to the same depth. And even though they have drastically different shapes and drastically different volumes, because they have the same depth, they're going to have the same pressure. Hopefully remember that the pressure at the bottom of a fluid is a product of the density, the gravity, and how deep it is, the depth of the container. So even if I wanted to get the pressure at the bottom of this container, all I would need to do is know the depth of the container. The fact that it's a semicircle for parts of it and flat on the bottom makes no difference. The pressure is simply determined by the fluid, the gravity, and the depth. If I want to get the force on the bottom, I take that pressure and I multiply by the area. Remember that pressure is caused by the weight of the fluid that is directly above that spot. You don't count any of the fluid to the right, to the left, forward, or backward. It's just the fluid that's right above it. I also would like to remind you of the force buoyancy. So when I put an object in a fluid, you'll notice that the object sometimes will float. There is a buoyant force pushing up on the object, and that's because the pressure on the bottom of the object is less than the pressure on the top of the object. That creates the buoyant force. You'll notice with the tennis ball, it sits about halfway under the fluid. That means the density of the ball is about half the density of the water. You'll notice with the golf ball, it actually sits underneath of the water, so this golf ball is denser than the water. Same thing with this metal ball. I put it in there and you'll notice it goes right to the bottom. That object is much denser than the water that it is placed in. If the object was the same density as the water, it would float, not on the bottom and not on the top, but wherever you put it in the fluid. That again is called neutral buoyancy. I have the metal ball tied to a string, and when I place the ball into the water, the ball won't go all the way to the bottom because now I have force tension working along with force buoyancy to cancel out the force gravity.